All right, folks. So we just finished with 16.1, and I just want to remind you a couple of things about 16.1. Here we go with this. We have we're on the autonomic nervous system. We're talking about the main divisions between the sympathetic and parasympathetic divisions. So we talked about that parasympathetic and sympathetic divisions. And then what we said was the sympathetic was the thoracolumbar division, and we said the parasympathetic was the cranial sacral division. And that's about where we left off with 16-1. Now what we're going to talk about is the sympathetic nervous system alone, just the sympathetic nervous system. Well, there happens to be four routes that the sympathetic neurons take in getting to their effector organ or effector gland. Now remember, they come out of the thoracolumbar region, but there's four ways they get to their organ or gland or smooth muscle. And your book only really lists three of them. Well, your book actually lists all four of them, but it classifies them into three classes, and I kind of separate that one group into two classes. So I'm going to talk about four of them. Well, what you can see here is this. You always have this preganglionic neuron, the red one, the preganglionic neuron. And this preganglionic neuron is always going to synapse with this postganglionic neuron. Now, where it synapses depends on what route it's taking. And what you're looking at here is the sympathetic chain ganglia route. That's what you're looking at here. But this one over here on the left is a slightly different route than this one here on the right. All right. This one here on the right is called the spinal nerve route. And this one here on the left is called the sympathetic nerve route. Now that's different. Let me show you. Let's do the sympathetic nerve route first. My preganglionic neuron leaves my spinal cord through my ventral root. That makes sense because all motor neurons leave the spinal cord through the ventral root. Through my ventral root, and it goes through my white ramus communicantes. That's the white ramus communicantes right here. Here's the gray ramus communicantes. Now you're going to say, what's this right here? This is running back into the screen and out of the screen. So you're kind of looking down the spinal cord here, and this sympathetic chain ganglia is also going into the screen and out of the screen. It's running up and down right alongside the spinal cord, and you should recall this from lab anyway. This preganglionic neuron synapses with the postganglionic neuron right there in the ganglia of the sympathetic chain ganglia. And then the postganglionic neuron leaves that through a sympathetic nerve. This is the sympathetic nerve route. Okay, now let's look at the spinal nerve route. Similarly, the preganglionic neuron leaves through this ventral root. It goes through the white ramus communicantes. It synapses with the postganglionic neuron right here. And the postganglionic neuron leaves through the spinal nerve. Now this is the gray ramus communicantes, but it rejoins with the spinal nerve, and it goes to its effector organ or gland through the spinal nerve. By the way, look at something. You don't have to leave through the same segment that you entered. Let's say this is T3, all right? So this preganglionic neuron leaves at level T3, goes through the white ramus communicantes and synapses in the sympathetic chain ganglia at T3. And then right here, the postganglionic neuron leaves the spinal nerve at T3. But you don't have to do that same level. Let me erase all this garbage I'm filling up here. What can happen is this. This preganglionic neuron can go up or down. In this case, it's going down. Well, yeah, I guess it's going down. I guess you're looking from the top of the spinal cord. So in this case, it's going down. Oh, you are looking from the top of the spinal cord. How can I tell? This is dorsal, this is anterior. You're looking from the top down. And then you can synapse in the sympathetic chain ganglia at T4. Let's say that's T4. And then that postganglionic neuron leaves the spinal nerve from T4. So you can have intersegmental travel here when you through the spinal nerve route. All right. So that's the sympathetic nerve route and the spinal nerve route. And pay close attention to the preganglionic neurons and the postganglionic neurons each time. All right, another route. This route is a collateral ganglion route. It's quite often called the splanchnic nerve route. And here's why. Because they don't synapse in these sympathetic chain ganglia. They go to a collateral ganglion and they travel through a splanchnic nerve. That's what they're doing. All right, now, it's not, this is probably I just went backwards. This is probably a splanchnic nerve right here, too. I know I'm calling it the sympathetic nerve, but it is likely actually a splanchnic nerve. But the difference here is this. With the sympathetic nerve route, the synapse occurred in the sympathetic chain ganglia, and the postganglionic neuron is going through the sympathetic nerve. With the splanchnic nerve route or the collateral ganglia nerve route, the preganglionic neuron is traveling through the splanchnic nerve. It doesn't synapse until you get to a collateral ganglia, and then the postganglionic neuron goes out to its effector organ or effector gland. This is called the collateral ganglion route. So that's the third route you've learned. You learn the sympathetic nerve route, you learn the spinal nerve route, and now you've learned the collateral ganglion route. Lastly, and this is the tricky one, it's really similar to the collateral ganglion route, but this is called the adrenal medullary route. What happens is the preganglionic neuron goes out, it enters the sympathetic chain ganglia, does not synapse, goes through the splanchnic nerve, enters a collateral ganglion, does not synapse, and then travels to the adrenal medulla. And then what it does to the adrenal medulla is it tells it to release epinephrine and norepinephrine. Epinephrine and norepinephrine. But you're going to say to me, where the heck's the postganglionic neuron? That's what you're going to say to me. Because there always has to be a postganglionic neuron. Well, as it turns out embryonically, this adrenal medulla actually formed from postganglionic. Well, it actually didn't form from postganglionic nerves. How do I want to tell you this? The adrenal medulla are really just modified postganglionic neurons. So this cell right here, this black cell that you see here, it's a adrenal medullary cell. But really what it is, and the best way to think of it right now, is it's a modified postganglionic nerve. And it's going to secrete epinephrine and norepinephrine. Well, and it secretes them to the bloodstream because these epinephrines and norepinephrines are hormones. So it's going to secrete those hormones to the bloodstream. Well, if the adrenal medulla is modified postganglionic neurons and it's secreting epinephrine and norepinephrine, then these postganglionic neurons better secrete epinephrine and norepinephrine. They do. And these postganglionic neurons better secrete epinephrine and norepinephrine. Don't worry, they do. And these ones over here better secrete epinephrine and norepinephrine. And don't worry, they do. So these postganglionic neurons all secrete epinephrine and norepinephrine. And all that the adrenal medulla is these modified postganglionic neurons that secrete epinephrine and norepinephrine, but it's picked up by the bloodstream instead of by an effector gland or organ. And therefore they're hormones and they float around your blood and go to a target gland or organ. So am I telling you that sometimes that the same chemical could be a hormone and then it could be a neurotransmitter? Yeah, that's what I'm telling you. A chemical could be, some chemicals are, what do you call it when you have a second? They moonlight. Some chemicals moonlight as hormones. If they're neurotransmitters, they can moonlight as hormones. If they're hormones, they can moonlight as neurotransmitters. Some chemicals fulfill both functions as neurotransmitters and hormones. So those are the four routes that the sympathetic neurons can take. You have the sympathetic nerve route, right here. You have the spinal nerve route right here. You have the collateral ganglion route right here. We also sometimes call it the splanchnic nerve route. And then we have the adrenal medullary route right there. So those are the four routes the sympathetic neurons can take. All right, now there's three pathways based on synapse, and this is the same darn thing I just told you. This really is the same darn thing, okay? You can see, let's just see what this is. Well, this is the spinal nerve route. How do I know? Because I looked at the label, and that says that's the spinal nerve. So this postganglionic neuron is using the spinal nerve route. It's synapsed in the sympathetic chain ganglia. It's synapsed in the sympathetic chain ganglia, and it's going out a spinal nerve. That's the spinal nerve route. This is still a spinal nerve route, but this is showing you something different. It's showing you that you don't have to stay at the same level. You could enter through, say, T4, travel upward, and exit through T3. You could do that, so you don't have to stay at the same level. This is showing you a collateral ganglion route. And just like I already talked about, you go through the sympathetic chain ganglia, but you do not synapse there. Okay, so you're going through your white ramus communicantes there. You don't go back through the gray ramus communicante. Well, you actually could. Let me see if the previous one showed you that. No, it didn't. It didn't show you going back through the, oh, that's the adrenal medullary. Yeah, it didn't show you going back through there. Good. We'll stick with that. So you're not synapsing in the sympathetic chain ganglia. You are not. And then you go out to a collateral ganglia and you synapse, and then your postganglionic neuron goes to its effector gland or organ. So these are based on where you synapse, and there's only three pathways based on where you synapse, because what they didn't do is they didn't divide up the spinal nerve and sympathetic nerve route, because they both synapse in the sympathetic chain ganglia, so they didn't really consider them different. Now, let's look at the ganglia, because they're all, well, except for the adrenal medullary route. The adrenal medullary route, its only synapse is in the adrenal medulla. But the other routes, they all synapse in a ganglia. They either synapse in a sympathetic chain ganglia or they synapse in a collateral ganglia. So let's look at these ganglia. You guys already know the superior cervical ganglia and the inferior cervical ganglia. You already know it. You learned it in lab. So this is all part of the sympathetic chain ganglia right there. You already know the thoracic sympathetic chain ganglia. You already know that. Now look at these nerves. They enter these plexuses, like the cardiac plexus. You learn the cardiac plexus. You learned that. You learned the esophageal plexus. We were able to see that on the models. You learned these. All right. Now look at this. Look at my splanchnic nerve. I have a greater splanchnic nerve going to the celiac ganglia. I have a lesser splanchnic nerve going to the superior mesenteric ganglia. I have lumbar splanchnic nerves going to the inferior mesenteric ganglia. So I have these splanchnic nerves. I have sacral splanchnic nerves. So they go to a plexus. So I have these splanchnic nerves. Now let's recall what it means to be a splanchnic nerve. It means you're going to a collateral ganglion. That's what it means, that you're going to a collateral ganglion. So these splanchnic nerves are going to carry neurons to typically through a collateral ganglion. Now I have a question for you, by the way. Do you let me erase this and get it out of the way. Erase that too. The parasympathetic nervous system was called craniosacral. Craniosacral. And you can see that my sympathetic chain ganglia, right here, here's my sympathetic chain ganglia, goes above T1 and goes below L2. Down here, do you think these might carry a mix of sympathetic and parasympathetic neurons? because my parasympathetic neurons are craniosacral. They come out of the sacral region, but you can see that my sympathetic chain ganglia delves into the sacral region. So maybe right in here I have nerves carrying a mix of sympathetic and parasympathetic. That could be. What do you guys think? And of course it's rhetorical because you can't answer me, but the answer is yeah. Some of these nerves can carry a mix, can carry both divisions of the autonomic nervous system. Some of these nerves do that. All right. I guess I'm done showing you these ganglia. This is the collage showing you everything. So that's the collage. Different picture showing you the same ganglia that I already showed you with these splanchnic nerves. It's just a different picture, not in your book. I like to mix it up a little bit. So you can see these inferior mesenteric ganglia, superior mesenteric ganglia, celiac ganglia, these splanchnic nerves, lumbar splanchnic nerve, lesser and greater splanchnic nerve. So you can see these right here. All right. So that's another way of looking at it. All right, that's it for 16.2, folks. Next part will be multiple, I believe. It'll be more than just 16.3.